The Daihatsu Mira is a kei car and city car built by Japanese car maker Daihatsu. It has a variety of options and chassis variations, with the latest variant having 4 models: Mira, Mira AVY, Mira Gino, and Mira Van. The Mira is the later successor to the line of cars begin with the Daihatsu Fellow of 1966 and was originally introduced as the commercial version of the core. Outside of Japan, the Mira has also been offered with larger 850 or 1000cc engines. In Australia, the two-seater version was marketed as the Daihatsu Handy Van and later as the Daihatsu Handy. The dimension of the Daihatsu Mira is 3.295 meter length, 1.395 meter width, and 1.415 meter height. The Proton Putra is a coupe automobile produced by Malaysian Automobile Company, Proton. Production of the Putra started in late 1966 and ended in 2001, but was briefly relaunched in limited numbers in 2004 for the domestic market. The reasoning for the relaunch is the clearing of the remaining stock available at the factory. The dimension of the Proton Putra is 4.225 meter length, 1.690 width, and 1.365 meter height. The Volkswagen Beetle, officially the Volkswagen Type 1, is an economy car that was manufactured and marketed by the German company Volkswagen from 1938 until 2003. It has a rare engine design with a two-door body style and is intended for 5 occupation. The dimension of Volkswagen Beetle is 4.079 meter for the length, 1.539 meter for the width, and 1.477 meter for the height.
As you can see in the slide, this is the drag coefficient data obtained from the cars we choose. The first car is the Daihatsu Mira. The first velocity is 27.78. Drag force is 249.74. Frontal area is 1.58. Air density is 1.225, so we get the drag coefficient in 0.334. The last velocity for the Daihatsu Mira is 55.56. Drag force is 998.96. Frontal area is 1.58. Air density is 1.225, so we get the drag coefficient in 0.334. Thus, for the Daihatsu Mira, the average drag coefficient that we obtain at various velocities is 0.334. The next car is a Proton Putra. The first velocity is 27.78. Drag force is 249.74. Frontal area is 1.86. Air density is 1.225, so we get the drag coefficient in 0.284. The last velocity for Proton Putra is 55.56. Drag force is 998.96. Frontal area is 1.86. Air density is 1.225, so we get the drag coefficient in 0.334. Thus, for the Proton Putra, the average drag coefficient that we obtain at various velocity is 0.284. The last car is a Volkswagen Beetle. The first velocity is 27.78. Drag force is 249.74. Frontal area is 1.82. Air density is 1.225, so we get the drag coefficient in 0.290. The last velocity for Volkswagen Beetle is 55.56. Drag force is 998.96. Frontal area is 1.82. Air density is 1.225, so we get the drag coefficient in 0.334. Thus, for the Volkswagen Beetle, the average drag coefficient that we obtain at various velocities is 0.290.
This graph data is based on the calculation that have been made to take the drag coefficient with different velocity. The average drag coefficient for a car is the same even with different velocity condition. The drag coefficient data we have obtained for the Daihatsu Mira brand is 0.334, for the Proton Putra brand is 0.284, and for the Volkswagen Beetle brand is 0.290.
Okay, hi, my name is Muhammad Najmi bin Azhar Shah. My matric number is 01DAD21F1019. Now I will continue about the discussion of our case study. Okay, vehicle dynamics is a broad field that encompasses many factors that influence a vehicle's behavior, performance, and efficiency. The focus of this assignment was of investigating three distinct vehicle models to determine their dimension and then derive critical parameters such as frontal area, meter square, and drag coefficient. This task required through understanding and application of vehicle dynamic principle. To begin, the investigation of three different vehicle models provide a diverse range of shape, size, and design, allowing for a comparative analysis of their aerodynamic characteristics. Understanding each model's dimension, such as length, width, height, and other relevant measurements, was critical in calculating their respective frontal areas. As shown in the graph, there are three vehicle types: Daihatsu Mira, Proton Putra, and Volkswagen Beetle. These three vehicles differ in width, length, and height, resulting in a different drag coefficient for the three vehicle model. The CD is 0.334, 0.284, and 0.290. In this graph, we investigate the drag coefficient of these three model vehicles when driven at 5 different speeds ranging from 28.08 to 33.33, 38.89 to 44.44, and 55.56. All three model vehicles are flatlined from the start of the velocity test at 0 to 27.78 until the end of the velocity test. Okay, that's all from me. Thank you.
Conclusion from this case study: to sum up, this research of vehicle dynamics highlight the significance of comprehending aerodynamics in assessing and improving a vehicle performance. It does this by concentrating on the computation of frontal area and drag coefficient of three different types physically. This procedure demonstrates how theoretical ideas and real-world measurement can be integrated, contributing to a deeper understanding of vehicle behavior and supporting the improvement of the automotive efficiency and design. Thank you.